Hello and welcome everybody to this presentation about OPC-UA and security. My name is Christopher Anhalt. I work as Vice President Product Marketing for Softing Industrial, and I'm glad about this opportunity to represent the OPC Foundation. As you may have heard already, unfortunately I have a runny nose today. Sorry about that, but I hope you can hear and understand me fine nonetheless. We all understand that many IoT applications, IoT solutions require access to machine data, or in other words, access to machine data has become relevant throughout the enterprise. And in order not to create any additional security risks, the communication of that data, access to data has to be secure. This means security, first of all, has to be flexible, as no two IoT solutions are the same, as IoT solutions often change over time. Security has to adapt flexibly to all these different solution scenarios. And that means security, for example, has to support a range of different data sources and devices. Security has to support different applications and associated user roles. There has to be security within complex network topologies, and security needs to provide ways to deal with a large number of client and server applications connected in the solution. The second need is cost. Of course, security comes as a cost. There is a trade-off between effort, cost, and level of security, and security mechanisms in the solution need to be cost-effective so that they can be applied successfully. And the third aspect here, and that's, if you want, on a separate level, I mentioned already IoT solutions change over time. Also, security threats are a moving target and change over time. And that means that a security solution that may be considered secure today may no longer be secure, for example, in 2 years or 3 years from now on. So the user needs to have processes and mechanisms available which allow the user to keep the security of the solution up to date, which means there have to be software updates, including fixes, maybe also new security features which can be deployed in the future. Now, which are the security features that OPC-UA offers to users? First, it has to be noted that OPC-UA doesn't try to reinvent the security wheel. OPC-UA uses, reuses, leverages security mechanisms which have been proven elsewhere, of course, most notably in the IT industry. And OPC takes these mechanisms and applies them in a 3-level security model. There is application-level security using certificates. There is user-level security to ensure authentication of users, here again using certificates. And there is so-called transport-level security, which means that 2 OPC-UA components can encrypt communication. For those of you who know here security, the terms we are talking here about X509 certificates, for example, transport layer security standards. Now, these points here make sure that users can work with a rock-solid security model, can use state-of-the-art security in their solution. The second aspect, or third aspect here, counting bullets, is the choice that OPC provides regarding security algorithms. Again, you can imagine there's a trade-off between security level and resource requirements, memory, computing power, and offering a choice here means that users can select the correct algorithms for a given device. In particular, for embedded systems with limited memory, with limited computing power, it is also possible to implement OPC-UA functionality on such systems. And last but not least, OPC-UA makes all these security features configurable. Users do not have to use all the features all the time, which again would come at a cost. Instead, users can select and turn on those features which are relevant and should be used in their given situation, in their given project. Let's take a closer look at one specific situation, and this is the question how to deal with potentially a large number of components here, large number of data sources, and also maybe a couple of client devices, as you can see here in the picture at the left-hand side here. Sensors, PLCs, devices at the bottom, clients at the top, and connecting each application individually to all these data sources means that potentially a lot of application, a large number of, a lot of connections need to be configured, and that means effort. And the effort can be reduced by employing here an additional component in the middle, an OPC aggregation server, which can take all these many OPC data sources and make them available through a single server interface to the application. So an application has to be configured only against one single OPC server instead of hundreds or maybe even thousands. And the second aspect of that image is, and I'm coming back to configuration, that it may not be necessary to use all security features here in the communication between a device and the integration server. Maybe authentication is enough, but you do not need encryption. But most likely you want to use full security when communicating with a client application and that server in particular, for example, if you want to connect a cloud-based IoT platform. So such a component is a key component which can help to reduce overall complexity of a solution, and which can help to reduce maintenance and configuration efforts, and hence which can keep the cost of operation down. Last remark on that slide, these components don't exist only on PowerPoint. You can buy a so-called secure integration server from Softing, and you can buy similar products from some of our competitors. So all this is commercially available today. To summarize, the OPC standard leverages established and proven IT security standards. It doesn't reinvent the security wheel. OPC security offers flexibility. In particular, OPC security scales with the solution. You can connect many devices, a huge number of data sources in an efficient way. And on a separate level, the OPC Foundation provides a forum for its members, for users to discuss security, and it helps its members to keep security of the solution up to date throughout the entire life cycle. Thank you.